And thank you so much for welcoming me here in Medellín. And thanks to Carlos and Christian for organizing this event. It's a pleasure to be here. And today I'm going to talk about the unidirectional data flow. And we'll be using two major Android libraries. We'll be talking about Kotlin as well as live data. So before we dive into the technical details, I wanted to tell you guys a bit about myself. And if I start talking too fast, just feel free to raise your hand and I'll know that means to slow down, because sometimes when I get excited and I'm talking about something, I can get really fast. So don't be shy to do that. So I worked at Google on the ad partnerships team, helping businesses grow their ad business in terms of user base. And from there, I transitioned to the engineering side, and I started in Android development back in 2014. And I joined the team at eBay that was building a local marketplace for buying and selling. And then from there, I joined the larger selling team at eBay, building out their Android app as well. And I originally wanted to come to Medellín for a month, and I unexpectedly decided to extend another month and a half. So I'm on 2.5 months in because I loved it so much. And yes. Yeah, so I extended because I loved it so much, and I was really interested in exploring both the Android community, and I'm really passionate about cryptocurrency and learning more about that. So it's been amazing to go to the AR talk in March, and that was my first event with the Medellín Android group. And then the last week I've actually explored what the Dash team is building, and it's a cryptocurrency project that's building open finance tools for the globe. So that's been really interesting to learn about that, because they have a really strong presence here in Medellín. So today we're going to be using Coinverse as our architecture example. And what Coinverse does is it scans the globe for the most relevant news in the cryptocurrency space, and then it converts that to audiocast, so you can listen to content on the go. And the idea is really to help filter through a lot of information that's out there. I love listening to podcasts, and I'm interested in crypto, so that's really what gave me the idea for this app. And I've been working on it for the last 10 months. And it's been a lot of fun.
Sorry, I want to change this.
Quick timeout.
We need to edit this on the video. I think that works.
If not, I can act it out. If anyone's a good drawer, maybe. Oh, we got a whiteboard.
You had the whiteboard.
Yeah. No?
Don't touch it.
Let's see. 58.
No, but it's keeping flickering.
I think it's the HDMI cable, but
Bro.
no,
Yeah, it's the
sucks.
no. I think it was better with the other one.
Yeah. Okay. Vale. Ponte el otro. Cristian, dame un minuto y miramos con esto.
Sí.
So this is it. Warming up.
¿Qué hace ahí? ¿Qué hace ahí?
I think it's better. No.
Con el primer.
Yeah. It's all good. All right. Back to it. So, as a recap for the commercial break, so I was interested in podcasts and cryptocurrency, and that inspired me to build Coinverse starting 10 months ago. So when we talk about the unidirectional data flow, it's sometimes also called unidirectional data or state flow, and it really became popularized by Facebook with their web development tools. Gonna say. So it became popular with Facebook with their web development tools, and maybe if I watch it, I feel like it will behave. And the real purpose was to manage the app state. So we'll talk about the 3 different areas of the view state, events, and view effects. And the first talk I saw that really started popularizing this for Android was in 2015. The SoundCloud team started prototyping it for their app, and they use the RX Java toolset to do that. Jake Wharton has done many great talks on RX Java, and that's kind of really set the fundamentals for the unidirectional data flow pattern. And then what we've seen in the last few years is a lot of startups and larger companies are adopting it. So I really started to consider it when I heard the Fragmented podcast by Kosha Kabal and I believe Don Felker. And when they really outlined the advantages and the simplicity of it, that's when I started to dig into how I could implement it in the approach we'll talk about today. So for the first iteration of Coinverse, I knew it was important to separate the business logic from the UI. Make sure that everything's separated and help reduce bugs and unexpected actions. So the MVVM model is a really good place to start for separating the logic, but I like to think of it as a lake. So there's lots of points where data or water in this example can flow in or out. So it can make things very complicated or complex and sometimes hard to tell what's happening or if there's a bug, exactly where that's occurring. So with the UF flow pattern, the great thing is that all of our view state data events, they come through a specific stream like a waterfall. So we can tell exactly when something is happening. And the reason that's important is because sometimes with an async task, for instance, we don't know exactly when that will return, or maybe it won't return successfully. So this allows us to handle those cases really well. And a nice side effect, because all of our logic is in the view model and repository, then it streamlines testing. So a lot of times for testing, you might have to mock different things. So this really helps with that. And then, as I said before, debugging, because we know when each state or event happens, when something breaks, we can point to that specific event. So a lot of the examples that I've seen out there, and you've probably seen as well, have done this with RX Java, which is a really powerful toolkit. But I was curious about seeing how to do this with live data. Live data has been introduced by Google a couple of years ago, and they've really been supporting it really well. A lot of things that are nice about it is it has built-in lifecycle support. So a lot of the app events that are tied to the UI are taken care of for you. It's flexible as well, so you can emit multiple events at one time, you can emit single events, and that's really nice for controlling the flow of information. As Coinverse expands, it's important to think about how new developers are onboarded. So live data code is very concise and it's easy to learn, so as Coinverse expands, it will be easy to work with other developers. So that's a nice side benefit. So I mentioned the view state events and effects before, but let's talk about what that means. So here's our main feed for Coinverse. And the view state shows us all of the persistent data. So for instance, here we have the feed type. So that shows whether the feed is showing ads or if it's going to be ad-free. And then we have the content list, which is the actual data. So this is the final persistent state of the app. In this example, a user is clicking on an item, and what's happening is that UI is sending an event to our business logic. So this is an example of a view event, and this is initiated in our UI, and then that stream is all sent to our business logic in one place. So view effects. Here, a user is swiping an item, and what's happening is when the item changes, its label is actually impacted as well. So that label change in business logic needs to interact with our UI. So this would be an example of view effect, when the business logic is telling our UI that some change needs to happen. So other examples of this could be like the navigation, it could be like a toast, or some sort of alert dialog. So how are we going to implement this? Let's talk a little bit about the structure. So we talked about our UI, we talked about the business logic, but let's talk about what that means in terms of Android. So our view here is our UI, and that creates our event stream. So all the events that happen are sent into our object and then passed into our view model, the business logic layer, in one point. So we know exactly where the information is passing through. And then in turn, our view, the only responsibility that that has is to observe the change in view state. So anytime the view state changes, the view will just update automatically. So the nice thing is that the view doesn't really worry about errors, doesn't worry about data inconsistencies, because that's all handled, as we'll see, in our view model. So our view model is our source of truth for our view state. As it gets events in from our view, it's then going to ask our repository or our network to get that data for us, and then it'll handle the different states. So it might be successful, it might not be. We can look at how this pattern helps us handle the different types of uncertainty there. So in our demo that we're going to take a look at, we'll look at Coinverse loading. So for screen events, those can be initiated by either a UI event, like the user touching a button, or it can be a system event. So here the onCreate method is happening, and then we are initiating this event to tell our business logic to load the screen. So in order to do this, we need to make sure we set up our models appropriately. So our view state, because this is storing our persisted data, we need to store that with a live data object. And as the live data object is updated, that will automatically update our UI. And one really important thing to note here is that the attributes stored in the view state are immutable. So what that means is we can't accidentally change the data from the view state. All of that is going to be changed in our view model. So we think about a stream, it's a one-way flow. So we want to make sure that the view model is updating the logic and that's flowing down into our view. Now for our view events and view effects, these aren't storing persistent data. So we don't have to store it with live data, but we can use Kotlin's seal class. And this is really nice because you can think of it as an emu, but on the class level. So we define a parent seal class, so for like view events, for instance, and then one of the view events would be screen load. And then later we can see how we'll use that when we're going through and parsing our requests. So our next step here is now we're actually looking at the view. So in this case, it's a fragment. So when we talk about a system event, we can see we have the onCreate lifecycle method here. And then we're updating the live data with the screen load event. And an important thing to note is that our live data object is storing an event type. So the event is emitting a single unique event. This is a pattern that Jose from the Android team at Google has developed and talked about. And I have the link to that in the talk notes that I'll link to at the end, and will be sent out to you guys to check out. But this is really nice because we can make sure we emit one unique event and we don't accidentally double track an event or have any redundancies there. So our view is streaming this event in our on resume. This will pass all of the events to our business logic. In this case, we're just looking at the screen load. So our view model sends the request to the network, and then it gets back the data. And we can look at how we're going to handle each of those different states. So in our business logic level, we can see how the seal class is useful. So with the when statement, we're checking our view event and looking at each type of view event, and then we can handle it accordingly. So for the screen load, we need to populate our initial view state data. And here we're going to populate the entire view state at once, because this is a screen load and we don't currently have any persistent data showing. And in order to do that, we'll make a network request with the get content list. And in this case, since we're updating the entire view state, we can update the whole live data object. But many times when we're updating a view state, it's important that we update just one attribute. So Kotlin has a really useful function called copy. And what that does is it makes a shallow copy of the object and allows you to select either one or many attributes to update. So that becomes really useful when updating the view state without having to change the entire thing. So now that our view model needs to get that initial content, it's going to make a network request. But in order to make sure we handle each case, there's a really nice pattern called LCE. And this simply stands for loading content in air. And again, we're using the sealed class here. And you can see that the types are generic. So what this allows us to do is for different use cases, we can pass in different types of content. So I like to create another sealed class that defines our type of result. For screen load, we're going to load our list of content. But for example, if we're trying to get a list of users, then this result, that sealed class would have another data class that might be users page list, for instance. So our network, we make our network request, and unfortunately there's an error. So how do we handle that? Well, in our repository, we want to first return a live data object, because our view model is taking that live data object and passing that to our view, which then observes it. So the type of information we want to pass back is based on the LCE result. So the great thing about this pattern is that we can handle each case accordingly. So when we initiate the network request, we can do an So we can tell our live data object that the information is loaded. So this is great because it allows us to handle that properly in our view model. And then when we have success, we can obviously pass back our successful result. And then we can also handle the error case. And I know a lot of times for myself, it can be a pain to go through and write error cases. And the nice thing about this is it just makes it very easy and seamless to add in. And if you have an LCE object that you're using, you're forced to actually in the view model, because if you use that when statement, you'll get that nice lint error that will nudge you to say, hey, you're missing a case here. So it really forces you to fill out the different use cases. So this part, our view model, our business logic, is handling our LCE response. So you can take a look at the loading content and error case. And it's important to know for live data that we are using a switch map here. And a switch map takes in a certain live data object, and then it emits a different one. So this is extremely useful because right now our view is observing the final state of the data, but what happens if we want to check if information is empty, or if we want to check another condition of the data? So this is where a switch map comes in, because after you pass in the first live data object, you can then check that value. And it's important to know that in order for that value to be emitted in the switch map, it has to be observed at some point in the view model. So if you use a switch map in your view model, but you never observe it, then it actually will never be generated. So it still has to be observed, but this lets you get the information a little bit sooner and process it. With that. So one great thing here is for our loading states, instead of the user having to wait to see the information, one new thing I added with this pattern that I did not have before is I actually call the room database. So while the data is loading, the user sees the existing data that has already been loaded. And then when the data has been successfully loaded with the LCE, we parse through that LCE.packet.pageless, and that returns the network request. In our case, though, today we have the error. So there's two things we need to do. One is we need to initiate the event for the view effect. So we need the business logic to tell the UI that, hey, something went wrong here. And in this case, we'll show a snap bar and say, hey, why don't you try refreshing or try the network request again later. And then the second part is we also load that room data, so that way, instead of it just being an error and empty screen, they'll have the data that's already persisted. So now that we've handled all of our LCE states, the only thing really left to do is observe the content list. And the nice thing about the view here is it's very simple. So we don't really care, like I said before, about the error, it's empty. We only update our adapter when new information is available. So, to recap, the unidirectional flow pattern is really useful for controlling our state events, and effects. It's really easy and simple to start with live data, which there's a lot of documentation examples from the Google team, and you can kind of start with that incrementally. And it also helps us handle many surprises. And as I was refactoring this, it really forced me to find some bugs in the code and really consolidate things. Like one instance, for example, is when I was first loading my app, I loaded the network request, updated room, which is the SQL layer, and then returned SQL. So SQL was the source of truth. And now with this pattern, as we saw, if we go back to the view model here, is I combined the room request and the network request into one call in the view model. So that way it's a bit smoother. So using live data for the UF pattern isn't perfect. There's a lot of customization that you have with coroutines and ArcsJava. So an instance of that is threading, where you can really control which thread you're on. So I'd say live data is a great way to get started, and then for some of the more advanced use cases, it can be good to explore other tools. Also, Google, and I'm sure there's new developments today since Google I/O is coming out with more functionality for live data, so it's just getting better as we go along. Also, live data, so as I noted before, you only observe, or you only can see the information that you observe. So what this means is that live data is really useful when you're working with UI, but if there's no UI, then some of these other tools might also be a better fit. So the next steps for Coinverse. So I went through and refactored the content, the main content feed with the UF pattern. And now that most of the logic is in the view model and the repository, I can start running JUnit tests without having to mock a lot of these UI components. So that's what I'll be working on in the next few weeks. And I'll also be expanding UF to the rest of the app just because of the performance benefits I've seen so far. And I did want to do one live demo. So let me just switch over here and show you guys another example. So prior to implementing it, I might need to reconnect. Let's see, I just need to reconnect with Pfizer. Un momento, por favor.
Rápido, Hurwitz, salen ahí.
Here we go. Okay, we're live. I'm just going to move us to the screen. So before I implemented the UF pattern, when a user was swiping through the main feed and they swipe a lot of items in a row, so what happened is, like right here we have an advertisement, and what's happening was a list of ads after you organize all your content. So one of the things that I thought about is, once UF Flow is implemented, I know exactly when the backend is finished labeling that piece of content and saved. So then what I did was checked the item above and below, and essentially what I said is the item above an ad is the item below an ad. And if both of those are ads, then I make a call to Twitter to refresh the ad feed. So as we see, this is going to work seamlessly. So we have two ads here. So when I swipe, it might take a few moments since I'm not on the Wi-Fi, but let's see if this updates for us. And yeah, there we go. So two ads went to one, and we don't have adjacent ads anymore. And yeah, that was really, that refactor really came with UF Flow, because after I organized things, I realized that, okay, here's this event is happening, and I was able to control that. And before that, I had some kind of hacky workarounds. So when there's adjacent ads, I did like a swipe to refresh, and then that just refreshed the ads for you, which is fine, but requires the user to know that that's possible for one. And yeah, this is not quite as seamless. So I think that's just one good example of how the UF pattern really helps clean things up. And yeah, if you're interested in checking out some of those resources I talked about in terms of live data or more talks on the UF Flow, because there's tons of talks from Instagram and Robinhood. I have a notes guide, so we'll send out the deck to everyone, so you can check out the Unidirectional notes guide or the live data guide. And I definitely would love for everyone to check out Coinverse. Shameless plug. Give me feedback. It's still in beta, so please break it and let me know how you did it. And yeah, if you want to connect to chat about Android or travel or anything else, my information disappeared, so. Yeah, but we'll be sending the whole deck out, and everyone will have access to that. So thank you so much.
Adam, is it okay for you if we make you some question about it?
Of course, yeah, I love it.
All right, sir. I know you have shared a couple of resources And also, you may find a lot of resources on the internet,
Yeah.
YouTube videos, different talks, blogs, etc., etc. But what is the best way in order to start applying the unidirectional flow pattern in a project?
Yeah,
Because you may find a lot of resources, but you don't know where
Right.
to start. So
Yeah.
where to start?
it's very daunting, and I listened to the podcast from the Fragmented folks maybe a few months ago, and I just like had so much going on that I was just like overwhelmed. I was like, I'm just gonna bookmark this for later. Like, it's just too much to deal with at once. But the way I started with it a couple weeks back is just learning about live data really well. And I think that's a good place to start because I had the logic separate already with the view and using the view model. But I was using some live data here, some observables here. It was kind of like mix and match. So my first step was just learning live data and converting everything over to that. Because there's definitely some interesting aspects of live data that's useful to know. So for instance, it's always important to make sure that it's mutable when you're sharing the information downstream. That way you don't like accidentally alter the information in the wrong place. And then there's other things with live data, like Jose has created a pattern with events, because sometimes you might accidentally double observe an event. So there's a few good best practices for live data that I recommend starting with. And the November Android Summit talk, I think, is probably the most recent live data talk. And I have that linked in the resource, but that one was good in terms of just, because I had live data working, but that one helped me really kind of clean up the code a bit. So I would start with live data, and then from there, you can incrementally add in like an LCE object for your repository, and kind of just go component by component. So it's really nice because you don't have to transition everything at once. You can pick one thing and start to implement that.
Thank you.
I have a question.
Sure.
What do you think about, it's another parent, software parent for model lawyer, domain-driven design, applying to repository lawyer. I mean, because that parent basically has three components: a domain, infrastructure, repository. What do you think about that?
Which pattern is that?
The domain-driven design.
The domain.
Like DDD.
Oh, okay.
DDD pattern.
Yeah, I'm actually not super familiar with that one, but it sounds like it's still separating out the different logic, like the UI from the business logic. So I think it's less important to like obsess on like a specific pattern, and it's more important to make sure you're following kind of the principles of separating out the logic, making sure you're testing the success cases, loading cases, error cases. So I think if you have an organized way of doing that currently, you don't need to like tear everything up and redo that. So I think it sounds like it's moving in the right direction. So.
That with respect that is, I feel that this pattern is simpler because if we are comparing with DDD pattern, you must implement a domain class, a repository class, and infrastructure class. So that's very interesting because.
Yeah, I'd love to learn more if you can send me some information. My email. Yeah.
Okay, I got one. That's
Christian, you tapped up.
in that same context. What do you think that has been the most valuable impact of the UF pattern on?
Yeah.
on this
So
case?
yeah, there's just so many bugs that were like uncovered when I started to implement it. Like I noticed like two things were happening at once, or like sometimes something worked and other times it didn't, and that was because it was like two asynchronous tasks. So sometimes it worked and sometimes it didn't because they were returning at different times. So this helped me really become more diligent. And instead of just calling 2 tasks and saying, oh, just we'll finish whenever, I call one, and then when that finishes, I call the other. So it really made me more organized in terms of those things. And I think a specific example of that is the JSON ads. That's a really good one. Also, with the screen load, like the example we talked through earlier, initially the screen had a flicker. It was like a very subtle flicker because the whole adapter was being updated when an ad was loaded. So with the UF pattern, I could listen when all of the news content was loaded, then update the ad information. So that way there's no flicker when ads are loading. So there's just a lot of quality things that I've noticed have improved. So it's been really nice.
Thanks.
I have a question as well.
Yeah.
Well, I can see that you're using a lot of LCD pattern, right?
Yes.
So if we start using the coroutines, do you think it's a really good idea to change the LCD pattern to start using the coroutines?
That's a good question. So I actually haven't worked with coroutines before. That's on the list for like the next frontier. But from what I hear and what I understand, definitely correct me if I'm wrong, because I'm not an expert, is that coroutines are really good for handling threading. So for instance, if I want to load, let's say like the audio cast with video, and I want to handle those in separate threads, with live data you can update on the background thread, but you can't create really other threads.
Yeah.
So from what I understand, I think coroutines would be really useful for optimizing some of the threading scenarios. But for the LCE stuff, that's something that would be good to look into. I guess how do you currently organize that LCE type of pattern with coroutines? Is that something that you currently do, or?
No, I just be looking for a chain or looking to see what is the best path to continue working.
Yeah.
Because I can see that the Sila class, you are going to make a lot of boilerplate. Yeah, this is only one class, but if you have to make a lot of view state or data, you are going to have a lot of boilerplate. I would like to avoid it.
Right. From one thing I saw today, I haven't had time to dig into the I/O talks, but I saw that there's some nice integration with coroutines and live data. So the Kotlin team is working with the Android core team to have live data work seamlessly with that. So I think it will work very well. So hopefully when I come back here, I can give a talk on that, if I'm welcome back.
It will be nice.
Yeah. Anyone else?
Yes, I have one.
Yes.
You talked a little bit about RX Java
Yes.
and also late data. How can you mix together? Like, how can you know when you use one and you use the another one?
Yeah, so originally I had some RX Java and some live data, and I made the choice to move everything to live data for simplification purposes. And as I mentioned in the talk, live data is really good for dealing with lifecycle because it's inherently lifecycle aware. But if you have a case where it's not dealing with your UI at all, so maybe you're processing the audio cast and doing text-to-speech conversion on the Android app, and that's something that is not really a UI task. So that's a scenario where you might want to use RX Java instead if you're not interacting with the UI at all. But in that case, I would also ask if you could be doing that task on the back end and offload that on a server. So that's one thing I actually did with the audiocast conversion, is that's written with a Firebase cloud function. So every time a user clicks on an item, it then asks the cloud function, hey, is this already converted to an audiocast? If so, it returns MP3. And then if not, it does the conversion. So I would say that RX Java, if it's a non-UI related task, and then I would also ask yourself, is it something you can offload to the server? And that has a lot of benefits for the user in terms of saving battery time, and saving data charges for network requests, things like that.
Yeah, I think that you can, if you want it, you can keep all the logic, inner connection, database connections, and getting all that data flows with RxJava.
Yeah.
Then in the view, within the view module, you can just post all the values to the live data. The live data will, the view will be absorbing the live data, so you can integrate it both. But yeah, I think that you are just doing 2 or 3 steps in order to have something and to mix stuff. That you can do it all in one way using live data or even coroutines plus live data.
Yeah. Yeah, I'm definitely excited to dive into the coroutines. Yeah. That'll be interesting.
Si alguien tiene preguntas en español, hacerlas.
Sí, las hacemos y
Traducir.
ahí intentamos traducir.
Sí.
Question: are you familiar with these architecture from Airbnb that is inspired in React Native? I find this architecture very similar to this one.
Yeah.
What is the main difference?
So I think it's very similar because it actually probably comes from that library. So the React Native library is built by Facebook, and I think it was Redux and another UI library, and that was maybe like 5-6 years ago. And then the Android side kind of adopted a lot of those Redux patterns. So I think they took an inspiration from Airbnb's approach there. So the things that are different, it's a good question. Yeah, I would say, yeah, maybe with the live data, you have a bit of mixing different libraries. So you might use like live data, like I said, with RxJava, whereas with Redux, since that's been kind of the gold standard for web, a lot of the functionality is built into that. So since Android is a little bit newer, I think some of those tools are probably still being built out. But it's very similar since it directly extends from Facebook here.
I would like to just say that it was good to see that how you solve this case. You know, if you're familiar with redundancy rules, you know there's a very similar do tree game, right? Where this is stage to simplify event to not invade the browser with lots of events. But what you did about the example when you have this post and they remove, you cannot have to advertisement at the same time.
Right.
That's a very smart idea.
Thank you.
It's over the simplification of the UI events, but also about the context of the domain itself, right? So I like the idea. I think it's very successful.
Appreciate it. Thank you.
Are you supporting orientation changes or just?
Yes. Yeah. You can take it for a spin. Yeah. So we are. Let's see. And then. Yeah.
And are you managing all this kind of logic from the fragment activity or within the view model?
That's a good question. So you actually can turn the view state into a parsable, and you can save the entire view state for configuration changes. I actually haven't taken that step yet. Everything is stored in the view, so the onSave state saves that. But since the view state persists the content list, I don't really need to save that separately as like a parsable. So the only thing I'm actually saving in the view state, I think, is the order of where you are in the feed. So that way it shows properly in the list. But yeah, if you do have a ton of information, then you could definitely use the view state with this pattern to store that.
One last question. What about how are you doing the testing? Did you have any UI testing with Espresso, or are you doing the unit testing just using Raw Electric? Or?
Yeah, so right now I don't have any testing. So this was one of the major reasons for adopting this pattern. Was I realized, like, all right, if I'm going to test this thing, it's going to be really tough with mocking all of the UI states. So in order to get serious about testing, This was one of the first main steps to do that. So my game plan moving forward is now I can use JUnit testing for the view model. So I can say, okay, let's call it screen load, and then probably we'll have to mock the repository. But besides that, since all of the view states and events and effects are in the view model, I can just say, okay, let's call it screen load. Let's make sure that the list is not empty, and then you can fire some errors and make sure the right effects are showing accordingly. So it should be straightforward for JUnit testing. So hopefully I don't have to do too much mocking.
Another question: How do you handle the HTTP request using that part of your project?
Yeah, so I'm using the retrofit library, and then I was originally using ArcsJava to return the response, but now I switched that to use the live data object, and yeah, so in the logic here, well, actually in this case I showed it's using Firebase, so I'm just returning a live data object from that. So for retrofit, that is being used for, actually I'm not sure if I'm using retrofit on the front. I think that might just be on the back end now because I refactored that with Cloud Functions. So it's actually just retrieving all that from Firestore now. And that has the easy like onComplete methods, the callbacks there. So.
But at that point, you need to transform I mean, you are using retrofit, but you know retrofit doesn't support like data callback. It's a
right.
thing.
There is a library that I used in the past, I know for ArcsJava, because they didn't natively support that. But since I refactored the Cloud Function, so what happens now is the backend service gets all the news sources and then saves that to Firestore. So all the front end has to do is just retrieve from Firestore. So I don't think I'm actually using any retrofit in the front end service now. It's all just pulling from either cloud storage or from the Firestore database. So it makes it really simple from a UI perspective.
Thank you very much.
Thank you.
Really, really great.